Hello there, welcome to Ethio-Hahu tutorial. I'm Getachew and today I'm going to do an exercise. A uniform solid sphere rolls on a horizontal surface at 20 meters per second and then rolls up the incline. If friction losses are negligible, what will be the value of h where the ball stops? Use g is equal to 10 meters per second square. This ball is initially moving at a speed of 20 meters per second and rolls up the incline frictionlessly. Therefore, we are going to find this height h. How can we find this height h? To find this height h, we use energy conservation of mechanical energy. When a ball rolls, in addition to its translational motion, the ball has rotational motion. Therefore, at this point, let's say this point is point A and this point is point B. In addition to translational motion, it has rotational motion. It rolls with an angular velocity omega. Since friction is ignored, mechanical energy is conserved. That means mechanical energy at A is equal to mechanical energy at B. When we say mechanical energy, it is the sum total of all energies, kinetic energy and potential energy. Therefore, this implies translational kinetic energy at point A plus rotational kinetic energy at point A plus gravitational potential energy at point A is equal to translational kinetic energy at point B plus rotational kinetic energy at point B plus gravitational potential energy at point B. Mechanical energy at point A is the same as mechanical energy at point B since friction losses are negligible. In the absence of dissipative force, in the absence of frictional force, total mechanical energy remains constant, which means mechanical energy at point A is equal to mechanical energy at point B. Mechanical energy is the sum of kinetic energy and potential energies. When we say kinetic energy is an energy associated with the motion of the system. Therefore, translational kinetic energy at point A plus rotational kinetic energy at point A plus gravitational potential energy at point A is equal to translational kinetic energy at point B plus rotational kinetic energy at point B plus gravitational potential energy at point B. Taking point A as a reference, gravitational potential energy at point A is 0. When the ball reaches point B, the translational speed of the ball at point B is 0 because the ball stops at point B and the translational speed of the ball is 0 and the rotational speed of the ball at point B is also 0. Therefore, at point B, we don't have translational kinetic energy and rotational kinetic energy. At point A, translational kinetic energy due to the translational motion of the center of mass of the system, that is half times m times v square plus rotational kinetic energy 1/2 times moment of inertia times omega square. This is equal to gravitational potential energy at point B is m times g times h. But what is the moment of inertia of a solid sphere? The moment of inertia of a solid sphere of mass m and radius r is 2/5 times m times r square. And from relationship between translational and rotational quantities, v is equal to r times omega, and this implies omega is equal to angular speed is equal to v divided by r. Therefore, 1/2 m v square plus 1/2 moment of inertia is 2/5 m times r square. Omega square is v over r the whole square. This is equal to m times gh. On both sides we have m. M goes with m. 1 over 2 v square plus here 2 goes with 2. R square goes with r square. We are left with 1 over 5 v square is equal to g times h. 1 over 2 v square plus 1 over 5 v square is equal to g times h. This implies 5 times v square, 5v square plus 2 times v square, 2v square divided by 2 times 5, 10. This is equal to g times h. This is equal to 5v square plus 2v square, 7v square over 10 is equal to g times h. Dividing both sides by g, h is equal to 7v square divided by 10 times g. This is equal to 7 times v is 20 meter per second square divided by 10 times g is 10 meter per second square. This is equal to 7 times 400 meter square per second square divided by 10 times 10, 100 meter per second square. Second square goes with second square. 1 meter goes with 1 meter. 2 zeros goes with 2 zero. 7 times 4, 28. 28 meter. This is the height reached by the solid sphere as it moves up the inclined plane. Therefore, the height of the solid sphere h is 28 meter. This is all about this exercise. Next time we'll do another exercise. Until then, have a nice time.